Welcome back to the channel. Today we're going to take a look at a differential equation. Differential equations are essentially equations that have derivatives in them or differentials, parts of derivatives. And the objective, you always want to know what you're trying to do, is you want to figure out what y is. You're trying to figure out what function, when differentiated, and then plugged into this equation would make the left-hand side equal to the right. The first thing you often want to do is check the left-hand side, because sometimes it's set up to be the derivative of a product, okay? So in other words, watch. If I take the derivative of y, I get dy dx. Nice. But the problem is, if I take the derivative of cosine, I don't get the other part of this term past the y. So the derivative of cosine is not -2 sine. It's close. If that 2 wasn't there, it would be an exact, and then we could really proceed easily here. So when that's the case, when you can't just interpret the left-hand side as the derivative of a product, then what you can do is make it the derivative of a product. All you have to do, though, is start fresh. Start with dy dx. So what I'm going to do is first divide through by cos. So if I divide through by cos, that's going to give me dy dx. So dy by dx, dividing by cos. Divide by cos. Well, sine over cos is tan. So that's going to be minus 2y tan x equals, and I've got to do what I do to one side, I got to do to the other. Divide that by cos. Well, that will become 3 over cos, or 3 secant. So what I'm going to do is think about multiplying through by some factor. It'll be a function of x, such that I can make this the derivative of a product. So when I do that, I'm going to end up getting what? ix. Okay, so what I've done is I've multiplied through by some, it's called the integrating factor, because it's going to allow us to integrate really easily. I know that the derivative of y is dy dx, but if I want this to be the derivative of a product, wouldn't it make sense to have I of ix, when it's differentiated, should be equal to the -2 I of x tan x? So we say minus 2 I of x tan x. Well, look, if I were to divide both sides by I of x, if you have a function in the denominator and the derivative of it in the numerator, then I think a lot of us know that that's a special integral. That's the natural log. The integral of that is the ln, the natural log of I of x. So what I do to one side, I got to do to the other. Okay, it's a balancing act. Those canceled. So what this turns out to be is I'm integrating the right-hand side, -2 of the integral of tan x dx. So if I want to take the integral of tan x, isn't that just the integral of sine x over cos x? Then I could use a u substitution, just let cosine be u. And of course, then take the derivative. So the derivative, left-hand side, the derivative of cos is negative sine. I'm going to bring the negative over. I'm going to fast track this a little bit. I could rewrite this as negative du over u, which is going to be negative ln of u, or negative ln of cos. So what I could do is take this and plug it into here. So this is going to be equal to, well, negative ln cos times -2 is going to be positive 2 the ln of cos x. And that's equal to the ln of the integrating factor, which is what I'm trying to solve for. So that tells us that the integrating factor is equal to cosine squared. So now I have my integrating factor. I'm going to erase all this stuff right here because I need some space. dy by dx minus 2 times y. I'm going to multiply this by cosine squared as well. Times tan x equals 3 secant x cosine squared. So what I can do is, now recognizing that that's actually the derivative of a product, then say that. Just say that's the derivative of the product of y and cos squared. 3 cos x. If I want to isolate y, all I have to do is undo d by dxing. Well, that's called integrating or anti-differentiating. Don't forget the dx, okay? And what I do to one side, I got to do to the other. Well, these cancel. So that gives me a y cos squared is equal to, well, what's the integral of cos? It's sine. So that's going to be 3 sine x. As soon as the last integration symbol drops, you have to place down your constant of integration. Now we've got it. We could divide both sides by cos squared if we wanted to. But look, they give us what's called an initial condition. So often, because this is a family, they're all family of functions that are separated by a vertical shift, we'd like to nail the one of the family. There's one family member we want. And it has to be the one that satisfies when y is 1, x is 0. So when y is 1, x is 0. Well, what does that tell us? If I plug those values in, the cosine of 0 is 1, squared is 1, times 1 is 1. So this tells us that c is 1. You can say y equals, I'm going to take the cos squared and bring it over to the other side. I know that this is now 1. So I'm going to have secant squared x times 3 sine x plus 1. You can see here now we have y, which is what we wanted. If I was to take the derivative of this and plug it into dy dx, and then take this and plug it into y, it would balance the original differential equation. All right, if you liked the video today, don't forget to slap a like on it. Don't forget to subscribe, and I'll see you right back here in the next video.